So this is an example of a sequence. You can see we have a list of numbers here. Each one is called a term. 5 is the first term, 10 is the second term, 15 the third, and 20 the first. You'll often see these denoted with a tiny subscript. So like A sub 1 is the first term, which in this case is 5. Whereas A sub 4 is the fourth term, which in this case is 20. If I wanted to find A sub 5, the fifth term, I'd have to try and figure out what my pattern is here. So when looking at these values, I'm sure you can tell that each one of these is going up a little bit, specifically by 5. We are adding a positive 5 to each of these values. So to find the fifth term, I would add 5 again and end at 25. Now I could continue this pattern of adding 5 to get more and more terms. And this is represented in what we call the recursive formula. So recursive formulas will always discuss what's happening to the previous term in order to get the next term. So like in this case, we are adding 5 to the previous term to get the next one. So the way that's written is we actually have A sub n this time, meaning I can find any term in this sequence by taking the previous term. So if A sub n is the term I'm on, the term before it would be n minus 1. Think about it. If I'm on the fifth term, the term before it is the fourth term, which is 5 minus 1. So the recursive formula will always have an A sub n minus 1, meaning it's in respect to the previous term. So this particular formula would be A sub n minus 1 plus 5. You can find any term by taking the previous term and adding 5, which is wonderful, except if I wanted to find the 100th term, it would take me a really long time because I'd need to first find the 6th, 7th, 8th, and all the way 99th term in order to get to the 100th. So that's where the explicit formula comes in handy. Explicit formula will relate everything to the term number, meaning n. So like for 5, n is 1. N is 2 for the second term, n is 3 for the third term, n is 4 for the fourth term, so on and so forth. So the explicit formula is going to again tell you you can find any term, but I don't need to know the previous one. I want to just know what term number I'm dealing with. So the best way to do that is sometimes people can look at it and see. So basically you're looking for a formula. If I plug in a 1, I get out a 5. If I plug in a 2, I get out a 10. If I plug in a 3, I get out a 15. 4 gets me 20. 5 gets me 25, so on and so forth. Sometimes you can visually see right away. If you're having trouble, think about the fact that whatever your pattern was, if this was an adding and addition pattern, that is going to help you figure out your explicit formula. In this case, I would take that 5 times the term number. Look back up at what we have at top. 1 times 5 is 5. 2 times 5 is 10. 3 times 5 is 15. 4 times 5 is 20. And it will continue to work. So if I really wanted the 100th term, if I wanted to know what A sub 100 is, I would take 5 times 100. 100th term of this sequence is 500. Let's try one more. So here's a new sequence, 3, 9, 15, 21. First, check out your pattern. What's happening here? We are adding 6 each time. Now, it's not always going to be an addition pattern. Sometimes it could be subtraction, multiplication, none of those. But in this case, we are adding again, this time 6. So the recursive formula relates everything back to the previous term. So A sub n minus 1 is my previous term. And basically, I'm just plugging in the pattern. So I take the previous term and I add 6. That's our recursive formula. Our explicit formula, we need to relate back to the term number, meaning 1 gets me a 3, 2 gets me a 9. If I plug in a 3, I get out a 15. If I plug in a 4, I get out a 21, so on and so forth. So if you're looking and trying to relate these numbers, maybe you can see how it's happening. If not, I recommend starting with your pattern. So if I took 6 times the term number, so in this first case, 6 times 1 is 6. What would I have to do to make that 6 into a 3? Well, I would have to subtract 3. And then see if it works for every time. So 6 times 2 is 12, minus 3 is 9. Yay! 6 times 3 is 18, minus 3 is 15. 6 times 4 is 24, minus 3 is 21. So it works for all of these. This is my explicit formula. Meaning if I again wanted to find the 100th term, I would take 6 times 100 minus 3. So the 100th term of this particular sequence would be 600 minus 3, or 597.